Now you will see substances that behave as if they are straight out of science fiction movies. Look at this. This one and this. Actually, no, this one really is from a movie. Well, there you go. This is definitely not a trick. And, as always, we've saved the most interesting stuff for those who watch the video until the end. Let's start, perhaps, with an unusual polymer called Terminator. If you remember the plot of the second part of the movie with the same name, you'll understand why this substance is called that. The polymer can become whole again if you divide it into several parts. Another material with similar properties is self-healing plastic. As soon as it is exposed to room temperature, the broken atomic bonds are restored. This happens in 97% of cases. These miracles are performed by aromatic sulfides that are part of this plastic. And here is another miracle material, Vantablack, the blackest substance on Earth. This unusual substance consists of vertically aligned arrays of carbon nanotubes. Such tubes are artificially grown on aluminum foil at low temperatures. They are packed so tightly together that they reflect only a tiny 0.035% of light, and 99.965,000% of the incoming radiation is absorbed. That's why Vantablack is so black. Because of this property, we perceive this material as if it's just a black spot added in a video editor. An object made from it doesn't look three-dimensional. Instead, we see a mysterious dark hole or just a black spot. On this super black substance, we also won't see any folds. Even if the material is heavily crumpled, the human eye won't recognize it. Another unique thing is a paint that makes things more durable. The Line X material creates long polymers that, when bonding with the surface of an object, form a dense layer of plastic. Take a look at these ordinary plastic cups after being coated with Line X. Even the weight of such a big guy doesn't bother them. Graphene is the strongest material on Earth, 300 times stronger than steel. A sheet of graphene, 1 square meter in area and only 1 atom thick, can hold an object weighing 4 kilograms. Graphene can be bent, rolled, and stretched like a napkin. Carbon has many allotropes. Some of them, like diamond and graphite, have been known for a long time, while others were discovered relatively recently, 10 to 15 years ago. It should be noted that graphite, which has been known for many decades, is actually a stack of graphene sheets, meaning it contains several graphene planes. Graphene was discovered by Russian scientists Konstantin Novoselov and Andrei Geim at the University of Manchester, for which they were awarded the Nobel Prize. And they obtained it in a very simple way. They peeled ordinary graphite using tape until they got a layer just 1 atom thick. Next, we'll cover the mysterious material Starlight. We covered it in a previous episode, so check that out if you missed it. In short, an egg coated with Starlight remained whole and liquid, even after being heated to a temperature of 1,500 degrees. Later, a National Aeronautics and Space Administration spokesperson confirmed that Starlight is not a fake and has unlimited potential for use. Unfortunately, it never reached mass adoption. The inventor held exclusive rights to the material and in 2011 took the secret of its production to his grave. There is also a special class of materials called aerogels. Essentially, it's a gel in which the liquid phase is completely replaced by a gas. It's often called frozen gas. Being a solid substance, aerogel can be made up of 98.8% air. At the same time, this material is super strong. It can withstand a weight 4,000 times greater than its own. This extraordinary substance was invented by the American chemist Stephen Kistler. Imagine, it was back in 1931. Almost 90 years ago, he published the results of his first astonishing experiments in a journal. In the 1960s, aerogels gained more attention and discussion. With extremely low density, aerogel has super low thermal conductivity. It's also very light. 150 blocks the size of a brick, weigh the same as 4.5 liters of water. Aerogel also has unique super-insulating properties. For example, this thin sheet can protect a flower from an open flame. The most extensive area of aerogel application is space. It is actively used by aerospace agencies as a thermal insulator. And here is a material that also loves heat, nitinol or titanium nickelide. It's an alloy of nickel and titanium that has very unusual properties. This substance can remember its original shape and return to it after being deformed. The effect is achieved by heating the alloy to a temperature of 650 degrees Celsius. The material is given the required shape, while its molecular lattice remembers its structure. Even if the lattice is later deformed, it returns to its original state. To do this, you need to heat nitinol to about 50 degrees Celsius. This broken paperclip became whole again after it was placed on the electric stove burner, or this wire, which returned to its original shape when placed in warm water. The heating temperature depends on the grade of the alloy. For example, these glasses can be bent any way you like at a low temperature, but at room temperature, they will return to their original shape. Do you remember the strange clock from our previous episode? They used ferrofluid, yet another substance that seems to ignore the laws of physics. It was created back in the distant year of 1963 by National Aeronautics and Space Administration employee Steve Papel. The scientist had to solve an important problem: how to make the liquid in a spacecraft's fuel tank move toward the opening from which the pump transferred fuel to the combustion chamber. So, Papel came up with the idea to add some kind of magnetic substance to the liquid. Ferrofluid consists of ultrafine magnetic particles, usually iron. When the liquid is exposed to a magnetic field, it starts to perform strange acrobatics and forms amazing structures. They are called ferrofluids, neurofluids. Each of these particles is coated with a surfactant that prevents them from sticking together. Essentially, ferrofluid is a colloidal solution, a substance that combines the properties of more than one state of matter, in this case, a liquid and solid metal. Ferrofluid has a very low coefficient of friction when in contact with a solid body. It can also penetrate very small objects and wet almost any surface. Gallium is a metal that becomes liquid at a temperature of 29 degrees Celsius. That means if you take it in your hands, after a few seconds, you'll find a warm puddle in your palm. This metal looks so much like mercury that, by mistake, footage with it even made it into our episode about the amazing properties of that metal. It's also amazing that if you put a piece of gallium in a glass of hot liquid, it will dissolve right before your eyes. Gallium has a unique effect on aluminum, causing it to become extremely brittle and fragile upon contact. However, gallium also has its advantages. It is sometimes used in thermometers. Helium-II. Helium itself is already unique. It is the only gas that liquefies at the lowest temperature, at minus 269 degrees. And even with further cooling, it remains in a liquid state, while all other substances on Earth become solid. But that's not all. In 1937, the famous Soviet scientist Pyotr Leonidovich Kapitsa conducted several interesting experiments. They showed that at temperatures below minus 271 degrees Celsius, liquid helium gains the ability to flow without any friction. This phenomenon was called superfluidity. For example, if you take a microscopic gap through which water would flow for many years, helium will pass through it in just a few seconds. This amazing substance was named Helium-II. Another super ability of Helium-II is its ability to very quickly form films on solid surfaces. Films of any ordinary liquid are very thin and spread slowly across the surface because of strong viscosity. But helium has no viscosity at all, so this process happens hundreds of times faster. The approximate speed is 20 centimeters per second. And now look at a substance called supercooled rubidium. It violates the laws of physics more clearly than anything else, specifically Newton's second law of motion. For example, if you push a door forward, it will move forward. But what happens with supercooled rubidium? As it cools down to absolute zero, rubidium behaves like a substance with negative mass. If you apply force to it, contrary to Newton's law, it will start moving in the direction opposite to that force. Do you know what the most amazing substance is? The one that no one has ever touched so far. Is it ether? Before Einstein, ether was considered a physical phenomenon, and Nikola Tesla saw great potential in it. Its existence was also proven in the experiments of Dayton Miller, back in the 30s. the American scientist experimentally detected the ether wind of light waves, which rendered the Michelson-Morley experiments invalid. They supposedly proved the constancy of the speed of light, which is what Einstein's theory is based on. Miller wrote to Einstein about the results of his 24 years of work, which confirmed the existence of the ether wind and therefore the ether itself. But Einstein ignored this information because it contradicted his ideas. It's not surprising that after Miller's death, his works never appeared in any scientific sources again. More about this in this episode. That's all for today. Which of the materials shown in this video would you like to experiment with at home? Write in the comments and rate the video. If you think the topic is worthwhile and want us to know our efforts weren't in vain, turn on notifications and see you in the next episode, which will definitely be a surprise for you.